Reading the rocks. Picture sandstone. Those are little ripple marks. Ripple marks are considered primary structures. They form with the sedimentary rock. Folds are secondary, as they form during deformation. This has microfaults. Faults can be tiny like this or massive. Scale is really irrelevant. Just a planar surface along where movement has occurred. That's a fault. Here we have diabase dike cutting granite. You see this a lot up here. And it's even offset. There's a little faulting. Some microfaults in that too. These would be primary structures too. But the iron, they're highlighted by iron deposits, which are secondary. Not really structure, it's chemical. It's just multiple folding episodes. Very complex folding. I can't tell, I think that it's hard to tell from the orientation of the rocks since you can't tell relative movement, but it's probably either Z or M folding. Let's explore the meteorites and fossils. Okay, now when you're looking for meteorites, I know people want to find them, but if you're looking, there's some key things to look for if you cut them open. Metals on Earth rarely form these hatch patterns in rocks. That's very rare, but it's common in metallic meteorites. Any sort of hybrechia like that, it could be, but then you gotta be careful because there's conglomerates like that here, except it's not iron, it's copper. So you gotta be careful. But something that looks like that, metallic with breccia around it, is a clue. But not all meteorites, not all metals in the meteorites will form that hatch pattern. You gotta look for other things. You see these pits here? That's a key sign of entry into the atmosphere. These dents and pits like this. Something burned. As you can see, almost all of these have something like that, unless they've been eroded, and rounded. So, I mean, there's gotta be some sort of crust that shows heating upon entry atmosphere. Quick tour of this section. I'll just talk and show some highlights.